in Trig, Chapter 4, Lesson 1, we'll be graphing the sine and cosine functions today. And we'll talk about what an amplitude and the period of the graphs are as well. On the next day's lesson, we will talk about if we shift the graphs right and left, or if we shift the graphs with a vertical shift of up or down, and how does that work with those equations. So part of the memorization for this chapter is, like I said, for this first day, we're only going to be dealing with the sine and this basic cosine. And we're going to talk about the amplitude, and that's going to be the opposite value of the a, which is in front of the word sine or in front of the word cosine. The period would be 2 pi divided by the b, which is the coefficient of the x right here. And today's graphs are not shifted up, down, or right or left, so it'll just be some of the basic sine or cosine graphs today. All the rest of that will apply to the rest of the chapter as we get to it. So going back to the unit circle again, we are going to talk about what the cosine at some of the main values. And so I'm talking about, like, for instance here, the cosine would be the x over r, so that would be 1 over 1, so it would be 1. We're going to go up here to 90 degrees, the cosine at pi half. Again, that'd be the x over r, so that would be 0. The cosine over here at 180 degrees, or that would be pi radians, that's going to be the x over r, negative 1. The cosine down here at 270, or 3 pi halves, that's going to be 0. And then cosine here is 1. The cosine here is 0. The cosine here is negative 1. The cosine is 0. And if you notice, the pattern will keep continuing around and around and around. 1, 0, negative 1, 0, 1. And so when we talk about a cosine graph, what we're going to be doing is the x-axis is basically going to be all of these radian measures. And the y-axis will be all of these answers right here on the right. The 1, 0, negative 1, 0, 1, 0. So therefore, your range of your graph is only going to go from negative 1 to 1. See, that's the lowest the cosine ever approaches, and that's the highest the cosine ever approaches. So again, we're going to be taking this basically from the unit circle, and we're going to take those radian measures as the x's. These answers over here will be the y values for your graph. The same thing's going to happen if we did the sine, except the sine is the y over r, so the sine here at 0 would be 0, because 0 over 1. The sine up here is going to be 1 over 1. The sine, that's 0 over 1. The sine at 3 pi halves, negative 1 over 1, so negative 1. The sine is back at 0. The sine is back at 1. The sine is back at 0. The sine is back at negative 1, back at 0, and again back to 1, and around and around and around. So when we go to ready to graph the sine graph, again, these are going to be the x values, those radian measures, and these over here are going to be the y values for the graph, and then we're going to make the graph of a sine function. So with that in mind, we're going to take a look here. So we have the graph of y equals 1/2 the sine of x. Well, first off, we already know to complete one full cycle around the circle is 2 pi units. So that's why I've done 0 and I've done 2 pi. I cut that in half, and that's pi. That's the middle. Then the middle between 0 and pi, that would be pi half. And the middle between pi and 2 pi is 3 pi halves. Now, we just did that a second ago on that unit circle. So remember, the sine at 0 radians, that was over here to the right on the axis. So the right side of my axis, that y value over r is 0 over 1. So the sine value is 0. Then you go back up top, the sine, the y value is 1. Then the y value is 0. Then the y value is negative 1. Then it is 0. So now, after we've done that, that was just plain sine of each of those radian measures. We had a coefficient of 1/2 out front, so that's going to be that vertical stretch. So we take a half of every single one of these answers, so it's 0, 1/2, 0, negative 1/2, and 0. So the original sine graph is here in pink. This is the sine of x graph. Notice it's going from 0 to 1 to 0 to negative 1 to 0. The half of the sine of x, it's only going to be half as tall. So notice it only goes to 1/2, 0, negative 1/2, 0. One of the things that I like to use that I had come up with a couple years ago, I didn't come up with the statement SOHCAHTOA, but I did come up with another way to use the word SOHCAHTOA. When you have the word SOHCAHTOA, you think of the s sub 0. So for the sine, that sine graph is going to start at the 0 value. The cosine graph is going to start at the value of a. So here's what I'm referring to. So for the statement SOHCAHTOA, from sine graph will start at the origin at 0. And this is what the basic graph looks like with a period from 0 to 2 pi. The cosine graph starts at the value of a. So basically it starts at positive 1, and again completes the full cycle in 2 pi units as well. Because remember, all the way around the circle finished our pattern for it to repeat again. So the statement SOHCAHTOA, I also use that for my graphs. So again, sine starts at the origin, the cosine starts at the value of a. Later when we get to tangents, I'll show you how to use it there for the tangent graph to go 0 asymptote, 0 asymptote. All right, so for our next example. So I want the sine of 1/3 of x, and we're going to compare that to the sine of 3x. So first off, the period. The period is 2 pi divided by the coefficient of x. So I need 2 pi divided by 1/3. Well, therefore then, 2 pi divided by 1/3 would be 6 pi. So it's going to take 6 pi units to finish the complete graph of the sine of 1/3 of x. So I like to take the table to go from 0 to 6 pi. Now the midpoint of that would be 3 pi, and the midpoint between those two is 3 pi halves. The midpoint of 3 pi plus 6 pi, that'd be 9 pi, cut in half. That's where the 9 pi halves came from. Now the sine graph a minute ago, I just said, using the statement SOHCAHTOA, the sine starts at 0 and then goes to 1. Okay, so it goes to 0, 1, 0, -1, 0. Now when we make our graph of this, this is the x at 0, y is 0. Then when my x is 3 pi, it comes back to 0 again. See, here's 3 pi 0 in blue. Now, at 3 pi halves, it was at a height of 1. That means between the 0 and 3 pi, right here is 3 pi halves, the graph went to a height of 1. And there's one complete cycle from 0 to 6 pi for the graph of sine of 1/3 of x. So I want to graph the cosine of a half of x. So again, the amplitude would be 1. There's just a 1 out front. The period would be 2 pi divided by the coefficient of x, which is 1/2. 2 pi divided by 1/2 would be 4 pi. So it completes the full cycle over 4 pi units. So in other words, we take this cosine graph right here, and this distance across from here to here would be 4 pi units, not 2 pi this time. It would be 4 pi because the period is 4 pi. All right, so once I've done that, 0 to 4 pi, again, I like to do the midpoint. So the midpoint from 0 to 4 would be 2, so there's 2 pi. The midpoint from 0 to 2 pi would be 1 pi. And the midpoint from 2 to 4 pi, you'd add them, that's 6 pi, cut in half, that'd be 3 pi. All right, the cosine graph, again, has started at the value of the a, which was 1 in this case, then it went to 0, to -1, to 0, and to 1. So that's where I got these numbers from, the 1, 0, -1, 0, and 1. Or if I think of the unit circle, if I'm at 0 radians, I'm to the right on the unit circle, that x coordinate would be 1. So the cosine there was 1. Then we go up to pi radians, that's up top. The cosine would be the 90 degrees, that's your x coordinate up there, which would be 0. And then you keep going around, okay? Because again, this is plugging in pi into that, so it really ends up at a half a pi. So the cosine at half pi is 0. You plug the 2 pi into this, so I'm looking at the cosine for 1 pi. That's going to be over there on the left on the unit circle now, which is the -1. And again, the graph, like I said, you then would plot your points. So this is at 0 radians, it's at 1. 0 radians is 1. Pi radians, it's at 0. 2 pi radians, -1. 3 pi radians, 0. 4 pi is back to 1. So the graph of y equals -3 times the sine of 2x. So again, the amplitude would be the absolute value of the coefficient in front of the word sine or cosine. So the absolute value of -3 is 3. So the amplitude is 3 this time. The period would be 2 pi divided by 2. 2 pi divided by 2 would give me a period of pi. So what's happening is, remember that on that sine graph, the entire distance across this parent function would be pi units. But we do have a negative on this coefficient this time instead of a positive. So yes, it goes up to 3 and down to -3, but a negative coefficient is going to reflect it over the x-axis. So instead of going up first, it's actually going to go down first. This one's going to go down first because of that negative coefficient right there is going to flip it over the x-axis. So one more time, the amplitude is the absolute value of the -3, which is 3. The period was 0 to pi. So again, 0 to pi. Cut that in half. Cut that in half as well. And then the midpoint of pi half and pi. And again, the sine graph, and remember that's the y values around the unit circle. The y value to the right starts off as 0. Or if we know the statement SOHCAHTOA, this basic parent function, the sine graph goes 0, 1, 0, -1, 0. So that's where these numbers come from. Now I have the coefficient out front of a -3, so I multiply every single one of these y values right here by a -3. So then I need to plot the point 0, 0, pi fourth is at -3, pi half at 0, 3 pi fourths is 3, and pi is at 0. So y equals 2 times the cosine of pi halves x. So again, the amplitude would be the absolute value of 2, so that's 2. The period will be 2 pi divided by pi halves. So the period this time will actually be 4, not 4 pi, just 4. So again, the period is 2 pi divided by pi halves. So that would be dividing fractions, easy as pi, flip the second to multiply. So 2 pi times 2 over pi. The pi's cancel, gives me 4 for the period. Now the amplitude was 2. So I took a look at the basic parent function for the cosine graph. Here's the basic parent function. The amplitude of 2 means instead of this being 1, this is going to go up to 2 and down to -2. And to complete the full graph from here to here would be 4 units across. That's what the period was telling me. So I can also make it set up an XY table for it. If I go 0 to 4, the midpoint of 0 and 4 is 2. The midpoint of 0 and 2 is 1. The midpoint 2 and 4 is 3. Cosine, the x coordinate on the unit circle to the right starts off as 1, and then it goes to 0, -1, 0, 1. We have a coefficient out front to multiply by. That coefficient in the front was a 2. So we take 2 times every single one of these values. Now, this is the x-axis. This is my y-axis for my points that I plot, and there is my graph. And remember I said it would complete the full cycle in 4 units long. That's the length of the period straight across here. The amplitude of 2 is telling me from the 0 line, basically. It's going up 2 units, and it's going down 2 units. So this one wants me to write the equation. See, is this a sine graph or is this a cosine graph? We'd have to know that first. So remember our basic parent functions from the statement SOHCAHTOA. Sine starts at the origin. Cosine start at the value of a. This graph starts at the origin. So from SOHCAHTOA, that makes this a sine graph. Now, does my sine graph here go up first or does it go down? It's going down. So therefore my a is going to have to be a negative value. How far down is that going from the 0 line? Oh, it's going down 3 units. So my a is actually going to be -3. Now, to find the b. See, one complete cycle here is pi units long. From here to here, the distance across is pi. So I know 2 pi divided by b has to equal that pi. So I put 2 pi divided by b, so we don't know, has to equal the full period of pi units. So that's 2 pi over b equals pi over 1. Oh, well, this would be 2 pi times 1 divided by pi, so b equals 2. So there's my final answer. Again, we found the a to be -3. We found this b to be 2, so we've just plugged those two in. Now, sometimes they don't give me the full graph. Sometimes they give me just part of the graph. So again, I have to ask myself, is this a sine graph or is this a cosine graph? See, does it start at 0 or does it start at the value of a? Hopefully you're thinking, oh, it starts at the value of a. That is correct. So remember the statement SOHCAHTOA, sine start at 0 and the cosine start at the value of a. So this graph starts at the value of a. That means my a is 4 in this situation, and it's a cosine graph. So it's a cosine graph, and a equals 4. Now we need to get b. We need the full period of this graph. Yes, the cosine graph, remember to finish it off, it has to go like this, all the way down to the low, back to the 0, and back to the high point. See, from here to here says that's 0, and that's pi. This is pi units long. There's another pi, that's now at 2 pi. Another pi would put me at 3 pi, and another pi would put me at 4 pi for the period. So one more time. So again, this is going from 0 to pi. To go from here to here is 0 to pi. Pi to 2 pi. Then I'm going to have to go another pi. That's 3 pi. And another pi would be 4 pi. And that finishes it. So the period here is 4 pi. So I know 2 pi divided by b equals 4 pi. So I'd say, okay, well, that's 4 pi over 1. So 2 pi times 1 divide by 4 pi. That's how I get b to be 1/2. Now I know a was 4, I know b was 1/2. We fill our numbers in, and there's our answer. All right, so for today's homework only, you have to remember that a is the absolute value. Absolute value of a is your amplitude. The period is the 2 pi divided by that b. Again, absolute value of a, the period. And that the sine graph starts at 0 from SOHCAHTOA. The cosine graph starts at the a value. And on the unit circle, the sign goes 0, 1, 0, negative 1, 0. And on a cosine graph, you start at the x coordinate on the unit circle would be 1, then 0, negative 1, 0, 1. That'll be all for today's lesson. And like I said, we'll work on all the rest of this throughout the chapter. And you guys, good luck to you, and we'll see you tomorrow.